Okay, perhaps we can start if I can ask, why is the edge becoming such a critical focus for observability today, and how is it transforming the way enterprises operate?
Yeah, hello, Phil. Listen, the edge is very exciting, right? Because there's far more devices right now on the edge that are centralized, right? And it's growing at a faster pace because the edge is where the digital meets the physical reality. Is where we human beings connect, right, to technology. We can touch it, we can feel it, they can feel us, right? So there's all that interaction. Whether you go to a store like those, Amazon Goes likes, right, and you have a bunch of cameras following you in order to do an automatic checkout, or you're in a factory with all the different sensors that are used by machines, or in a hospital, right, with all those medical equipment measuring vitals. Doesn't matter where you are, you're interacting in that physical world with digital technology. And so that's sort of the boundary, the connection. And so when you think about observability, is okay, we are used to observability using dashboards in looking at the data, the signals that are produced by the IT equipment, right? But the operational technology that is sitting at the edge, that the level of interactions with everybody changes the priority to really the real-time use of that. Sometimes it's security, sometimes it's enforcement processes. And because the connectivity to the motor ship is not reliable, right? You could lose connectivity. And even if you have connectivity, there's some delay. You really cannot trust on making the edge an extension of the cloud. So you have to treat that differently if you want to solve the problems that the edge is designed to solve, right? So really, it shifts the mentality of centralized understanding to collect and understand locally, and then you just shift the signal to the centralized location just to understand sort of the patterns, right? But that is a totally different way to treat information, and you have to account for that, right? So you need a different platform, a different observability platform. Normally, a lot of the observability platforms today, they are used to being deployed via SaaS on the cloud for centralized systems. But now, if you're going to be looking at the edge, you're going to have a more flexible hybrid platform that can deploy on the premises, near the premises, I should say, of where the zones for these edge devices sit. And you will have to have that flexibility, right? So that is what is changing in a big way.
Okay, so more and more data at the edge, latency an issue, and I think you covered it, but why can't we simply put all the edge data, just send it to the cloud? Is that a question of real time versus delay? What's going on there?
Yeah, so sending all the information to the cloud. Increasingly, these devices, IoT devices and edge devices, they are high volume generators of data. So sending all the data to the centralized system is just simply, I mean, there's the physics and the economics. We talk a little bit about the physics with latency, right, and the delay and the intermittent connectivity challenges. But there's the economics. Is sending all this data, massive data, is just not an economical formula, right? I mean, you will spend a lot of money doing that. So what needs to happen at the edge is all this data that is being collected, massive data, there you need to do the filtering there. You need to filter all the noise and get the signals, all those great signals and enrich them. You have a lot of context right there locally, and you need to enrich that because whenever you pass a signal to your centralized location, you need the context in order to make sense of that data. Otherwise, you will be speaking different languages once the OT data gets to the IT data, right? So there's the physics and the economics. Both are challenges, to make sense of the information that is being passed.
Yeah, and I think you referenced OT data there. So clearly, IT and OT systems are increasingly converging. Does that present some new observability challenges for enterprises, and how, if that is the case, how can they overcome them? How can they address them?
Yeah, there's challenges. I mean, the IT and the OT worlds are different worlds in a way. And as we say, maybe a lot of the data has different meaning for the people that are operating in those two different worlds. So so you need to unite. Basically, if you think about the OT, sometimes there's not a lot of maintenance there. It's not like a data center. You upgrade your servers. You are constantly involved, right, in looking at that up-to-date technology. In the OT side, you have a lot of legacy devices that are very old. There's a lot of data silos and fragmentation that happens. You have blind spots, right? And so you have to be aware of that because that presents attack surface areas. We can talk more about that, and then I make reference to the massive data streams that are there. So you have all these challenges of how do you converge, because you're going to have to use those signals. I alluded to the context that you need to pass in order to make it useful. So you need to unite these two worlds, and a lot of the times, in addition to cleaning the data, for example, you need to put that data in the same timeline, right, with the context, so you can establish and start making sense of that. Otherwise, this becomes different islands of information that people don't understand. So the temporal analysis becomes very important because you have all this fragmentation. So it helps also to standardize on observability on fewer tools and middleware, right? Because if you have an observability platform for the edge, and then you have one for your IT ecosystem, by definition, you have two silos to start with, right? So you need to have a unified platform that can manage both environments very well, so you don't have to worry about that, right? I mentioned that, for example, getting platforms that can be deployed near the premises in hubs that are close to the OT devices is a big advantage, because you shorten that distance to almost negligible, right? We talk about the physics. And then what you have is you can start defining zones that you can treat them differently from this standpoint of security. Because we talk about these blind spots, and that's very important, right? To have your architecture flexible, so you can optimize for security, performance, health, and everything, right? So, but yeah.
Yeah, I was going to come on to the blind spots. So perhaps you can say a little bit more about the risks created by blind spots at the edge and the ways in which observability can help organizations mitigate them.
Yeah, so the blind spots are, as the name implies, right, that you are not really monitoring those things. So normally those exist by a variety of reasons, right? We talk about legacy technology, but it could be also like these are sensors or devices that are sitting purposely in remote areas, and or yeah, they're not that well supervised. So the challenge there is, as we all know, we're familiar with the bad actors in the digital world. They will try to exploit everything, and what usually gets exploited is the lowest, the weakest link, right, in the chain. And so this blind spot present that problem because your attack surface includes them. So the observability allows to incorporate the data. And for example, if the configuration of an OT device change, that's interesting, right? Did you have somebody there changing it or not, right? So all that context has to be communicated, maybe to a centralized location. So you can see what if this is happening at the same time across that region, right? Like then that's a little bit of a pattern. So there's a lot of things that observability platforms can make those edge devices, blind spots, explainable. What is drifting, right? What is impacting them from the outside world, right? Like maybe somebody is neutralizing some of these devices, make them unfunctional. So there's a lot of things that observability platforms can, because they have the visibility of the whole system, right? Even if you don't get data from a blind spot, that is data indeed, right? That is information that you're getting. Hey, something is wrong, right? So, but increasingly also these blind spots. I mean, it doesn't have to be a security thing. It could be some malfunctioning. And you cannot rely on that device sending a signal to the mothership and saying, I'm bad, right? What if it's a medical device and it fails, right? You have to rely on this device itself to perform the appropriate action there. Maybe it's raising an alarm. I'm going bad, right? So the nurse can look at the patient that is using that device. But it's all about local detection and recognizing patterns fleet-wide. But the local detection and action is of key importance.
Again, I guess it's fair to say that many enterprises struggle with fragmented telemetry from their edge devices. Is there a way that organizations can turn all this scattered data into valuable, actionable insights?
Yeah, so that is a very important question, and we talk a little bit about how these are two different worlds, but even the devices itself, this is like different worlds. I mean, these are different devices. They use different protocols, standards, different rates of getting information. So how do you standardize a world where you have totally different forms of information in these devices? So I mean, when you're looking at data, you have to normalize things. So information database professionals have known this for years, right? And what observability platforms, the good ones, leverage is, in addition to observing the edge, as well as the centralized environments, you have a data lake where you are accumulating those signals that you're collecting, right? Again, we're not collecting the massive data volumes from the devices, only the signals, because that's where you want to do a lot of what we discuss as fleet analysis. But that's how you leverage that information that you're receiving. I also alluded to context. The local device is the best place to formulate and grab additional enriched with additional context. So indeed, you can normalize, right? There may be seasonality displays in the OT device. You need that context. So when it arrives to the to the centralized location, you can actually make sense of that and extract the unseasoned values, right? So there's a lot of the contextual enrichment that is needed. And then you need to layer, obviously, all the different external data that you can gather, like whether it's applicable geographical location, user feedback, all those technical metrics, because it's not just about the what, it's about the why, right? And so the why is important to make sense of that scattered data. And then eventually you will use it to act on it. And there's a closed loop there. At the end of the day, there's going to be somebody that will determine if the conclusion of the insight was correct or wrong. So if it wasn't correct, then you need to close that loop and see what happened, right? And then tune the system accordingly.
Again, it'd be good to understand how edge observability is becoming, I guess we call it foundational for autonomous and distributed systems. Thinking of things like industrial IoT and smart infrastructure, when I think you've already mentioned, but just why is it becoming so important?
Yeah, I mean, observability for me, I mean, just to put an analogy here, is like if you don't have observability, it's like driving with your eyes closed. It's like, you cannot see. Like if you're not, observability gives you the ability to provide the visibility, not only see, but making sense of the data we have established, right? So that is fundamental because, as we said, increasingly systems are becoming totally distributed. Even if they have a centralized way of making sense of the signals, as we discussed, you have to have the level of autonomy at all those devices. We talk about retail. We talk, imagine if those stores, you would grab 3 items and then you walk out of the store. You're supposed to check in, right? When you enter with your ID, cameras are watching you. You grab the items, there are sensors on the shelves, they're attaching that to your ID, you walk out of the premises, they know you have 3, 4 items, whatever, right? Imagine that the shelf is trying to connect centralized system and there's delay and it doesn't acknowledge that you grab something, right? Or that you walk out and you had to check. Now, I mean, you don't have the privilege of even like half a second of going back round trip. You have to act immediately, right? If you're in a factory, imagine you're in a line and there's a machine that is drilling 2 millimeter hole, right, in a surface for an electronic thing, and imagine that it goes out of calibration and starts drilling the hole a little bit to the right. You cannot just wait until that information goes up there because you're gonna waste maybe $1 million, right? And then trash it. You have to have sensors that are constantly detecting, and in the middle that it goes off, it stops or it adjusts, right? Even better. So the level of autonomy that is required for the edge to be successful requires to be disconnected if indeed is needed, and be able to grab all that intelligence and context locally, act locally. And again, I mean, it is almost seen as a nice to have to send the signal to the centralized place for us humans to see what is going on and to detect patterns. And I don't want to diminish that value because it's obviously there. But it's almost like flipping the equation. Is the most important piece now is the edge autonomy, and then collaborating with the centralized, right? As opposed to us thinking, oh, how can we incorporate the edge? No, it's really designing for the edge and then looking at how to plug those signals in a centralized fashion.
I see that. And in terms of the role that large language models, and everyone's talking about agentic AI now, I guess the roles those play in enhancing observability of the edge. I don't know if you want to say something, and maybe I guess the most important thing is the benefits that they can potentially bring.
Yeah, this is I'm very passionate, Philip, about this topic because I live in it's London County, which many of your viewers will be like, where is that? But if they search, they will know that it's a county in Northern Virginia in the US that has the highest density of data centers.
Data centers, yeah.
So approximately 80% of the internet connections in the world pass through here. And so I've seen obviously the importance of data centers. They cannot stop building more. But one of the things that we're used to the NVIDIA chips and how those have been really propagating as crazy. But one of the things that I also watching is how the edge is increasing in computing power. There's a lot of new chips that are actually probabilistic chips that are able to bypass all that very intense compute that the chips nowadays in data centers do to compute probabilistic algorithms, which are AI algorithms. But now they're putting that in hardware. And so then you need far less energy, which are tremendous help for the edge. And you can do that processing there. So the computing processing when it comes to AI is being distributed now to the edge and increasingly more. And then you look into algorithms, and we're all used to large language models, but a lot of the domain specific language, the small language models, are far more effective for the specific OT applications. And as the name implicates, they are less complex to leverage, but more effective. And then using RAG technology, you're accessing and enriching that small domain specific language model in those very efficient chips. And you're enriching them with context. So you're making actually the efficiency of the intelligence far more efficient than if you were doing any processing centralized with very powerful large language models. So the equation in the next few years is about to change drastically in favor to the edge. And the thesis that I'm seeing is like, you have the data increasing on the edge. And right now, as I establish all these data centers around me are processing in a centralized fashion this intelligence. That's going to start changing. We need to think about bringing the intelligence to the data as opposed to the data to the intelligence, right? So that's what I see things changing. So observability platforms that are incorporating the edge, that's not enough. When you look into their intelligence, you need to look into how they use not just large language models, but domain-specific small language models for this purpose.
Okay, and maybe just sort of perhaps expanding on that as we finish, the technology or approaches you think are essential for achieving effective edge observability, and you obviously mentioned some there, and the next evolution in this space, which maybe, as I say, you mentioned that we're almost going to flip it from being centralized large language models, the importance of, edge processing, if that's what we call it, is good. But please share sort of the essential components and then how you see this space evolving.
Yeah, so we talk about very essential components here on the increased power efficiency of use of the energy, the RAG, the context taking and localized data, enriching the outcomes of these, you leveraging this intelligence, the ability to have the autonomy and the disconnection of these systems and be able to deliver that real-time processing and business outcomes that are designed for without the need of connectivity to the centralized systems, and the ability to filter all the noise, right, before passing any data for cost. We talk about the economics in addition of the physics involved here. So putting all that together, those are the essential elements, right, of doing this. And so I think that there's going to be increasingly more and more applications on the edge that, again, are made possible because you have observability platforms that can make sense of the different, streams of signals with the context we also established because of all the fragmentation of the data. But increasingly, these observability platforms are going to be able to allow for all these broad array of solutions. We increasingly, human beings are going to be, whether we're traveling, as we established in retail and or the hospital, or in factories, or in the logistics, right? Like all our world is going to be connected through OT devices, are going to be everywhere, right? And everything is going to be making sense, not only into the centralized, even in as I established, if you have an observability platform that has the ability to be also deployed in clusters close to these zones, you're going to have very interesting solutions that are fast, that are real time, and that are able to affect positively our lives in a very efficient way as well, right? As we established in terms of cost and everything with these new technologies coming up. So I am very excited of what the world ahead has. And, ScienceLogic, we are building that platform, right, that can give the flexibility to our customers of having, visibility into this hybrid world that we just defined here in our conversation.
I'm just wondering as well, is it in terms of the observability platforms, will that define the successful ones or the ones that are useful, in the sense that, as you say, you want a hybrid one that can cope with sort of centralized and edge processing data, etc., as opposed to one that maybe is mainly centralized and then it's almost an afterthought, some edge capability is added. So it's got to be an integrated sort of from day one. Is that fair to say?
Absolutely, Phil. That's critical, right? You mentioned an afterthought. Yeah, afterthoughts will be just peppering the centralized observability system with data here, data there. That is not scalable when you have millions of OT devices out there. It becomes unmanageable, right? So yeah, I mean, you can use that the observability that is not integrated for a school experiment, but you are not going to use it for scalable, business enterprise deployment for sure.
Excellent. I mean, it's been fantastic to chat, and thank you so much for sharing so many great insights. I followed observability. I think I came into it when it was called AI. Well, AI Ops was one of the sort of flavors, and I know various different things sort of come together, and now observability is, very much here with the momentum. But it's been great to chat, and Arturo, thanks so much for your time. Appreciate it.
Thank you, Phil. Thank you for having me, and have a great day.